number 1. Is the following mapping a function?
Yes.
Yeah. Number 2, it asks us to simplify the expression. You had like terms you needed to combine. Negative 15k plus 2k gives you negative 13k. Negative 1 plus 12 is plus 11. Number 3, after the domain of these ordered pairs, that should have been a list. Least to greatest. Least to greatest, what are those numbers? So if they were not least to greatest, fix that. Number 4, you needed to combine like terms, but you had a bunch of things you needed to distribute. Yes. Yes, let me sign you out. Everyone's attention back up here. So distribute everything and then find your like terms. Negative 12 minus 2 is negative 14. Negative 14 plus 15 is positive 1x or just x. Negative 6 plus 6 cancels each other out, and you're just left with minus 20. Or number 5, if you missed the hint, you find the perimeter. You add up both of these sides and both of these sides. So 2 times your width and 2 times your length. That's the other one. So we would distribute or multiply here. 6y minus 10. Combine your like terms. So if we knew what y was, we could actually find the numerical perimeter of this, but we don't, so we're not going to. So the other 2y plus 2y, that's the same thing as multiplying it by 2. Any questions on any of these? Before we start our new units, this one, a couple things. 1, the quarter ends on October 29th. That's in about 4 weeks after this is 4 weeks from now. But if you need to retest any of Unit 1, any of Unit 2, you need to come do test corrections with me. Make sure you are not missing any. That's Math, Khan Academy. If you have a really low score, I'm going to give you extra practice. You'll need to do that. And get that retested before the end of October. Everything we're going to do in this next unit, so for Unit 3, will not be in this marking period. So all the Khan Academy grades, the test grades for this unit will be put on the second marking period. So when you go looking for those grades, that's where they'll be. So the last grades in this marking period for the Khan Academy that you were supposed to do Friday in the test. So if you've not gone back and done Khan Academy, make sure you go back and do those because your grade is not changing unless you retake or do your Khan Academy. That is it. Any questions on either of the things I just said? Ready. Let us start our new notes. If you are ready, I need your hands over here. Why are you caressing his side? Sorry. So, some of this may be review sheets, some of this may be brand new, either or, that's fine. So we're going to be solving multi-step equations in this unit. We're solving equations that don't just take like one step or two. So when you hear the word solution, what comes to mind? I see hands. Could you say?
So when you're solving a problem, you have to see so multiplying, you have to divide and stuff.
So, okay, you're talking about opposite operations. You don't need to write all of this stuff down. I'm just kind of writing some of the stuff you guys are saying. Sure. Operation. I cannot write that. It's fine. You don't need to write that. I'll tell you exactly what you need to write. Please. Any other thoughts come to mind? Anyone else have any other thoughts? All of these things are true. I'm going to kind of combine them and say the answer to the equation that makes it true. So when I find this solution, if I were to put it back in, it would make both sides equal to one another. It would make it true or equal. So to determine are these solutions or are they not, that's exactly what we're going to do. We're going to put it back in and see does it work or does it not. So we're going to put 5 in for x. I'm sorry, before we do that, did anyone else still need that? We're going to take this 5, we're going to put it in for x. Kind of like we were evaluating. So 13 times 5 minus 7 equals 58. I just put 5 in for x. 13 times 5 gives us what? Does 65 minus 7 equal 58? Yeah. So I can say that this makes this statement true because we put it back in and we get what it's supposed to equal. Number two, we should already kind of know that this one's not a solution because this is not -5, but let's still try it. Now put -5 in for x. Now we get -65 minus 7. What is -65 minus 7? -72. Do these two equal one another? No. So if we put a number back in and it does not work or it doesn't equal whatever the equation is supposed to equal, it's not a solution. So when we get into solving these problems, this is a good check for yourself. Put it back in, see does this work. If it does work, you did this right, you got the solution. If it does not work, something is wrong and you need to go back and fix it. I want you to try 3 and 4. I'm going to give you 2 minutes to do 3 and 4, and then we'll come back and we'll talk about it. Alright, for number 3, did we find this was or was not a solution? Was not. Did we all get was not? Anyone need to see that one? So I'm going to put this one back in really quickly. This should be 3. 4 times -2 is going to change this to a -8. 3 minus 8 is a -5. These do not equal. Those are not solutions. Did you get that this was or was not a solution? It was. And really quickly, I'll put that back in. Divide those by 2 to get -17. -17 plus 5 is -12. These are the same.
Yeah, so we have a matrix.
Yeah.
What is your question?
Still not a function.
X plus 4.
Okay.
So what happened was when I printed these off, the X like disappeared. So I forgot where the X went and I got kind of trapped. But yeah, I think it's still off. Any questions on how to determine is it a solution or is it not? On to the next page. So these words may look unfamiliar, but what Kavita said earlier about doing inverse operations is kind of what these are doing. Addition property of equality is adding to both sides. Subtraction property of equality is subtracting to both sides. Multiplication is multiplying to both sides. Division is dividing to both sides. Distributive property we've talked about before. That's not something you necessarily do for both sides, but it makes it equal, either or. So with these are solved for us. We just have to say which one did they use. When we do this, because sometimes it gets confusing. Number 1 is given because that's the original equation. When we look at number 2, we're looking at what changed. What did they do from here to here? And that's what we write down. So what changed? What happened? What is that called? They distributed the 2 to both of these. That would be your distributive property. And these other ones we may kind of need to think about. Here they have 2x minus 18 equals -10. Now they have 2x equals 8. What did they do from here to here? So, what did they subtract? So they subtracted 18 on both sides? They added it on both sides. Because we're doing the opposite. So they actually added 18 on both sides to get this positive 8. This would be additive property of equality. I'm just going to put 18. I'll fix all that. And from number 3 to number 4, what did they do? That's fine, so you guys all. They divided both sides by 2. So divide POE. Any questions on number 1? Let's get down and do number 3. I'm going to let you guys do number 2. So for number 3, again, this first one is given. That's the original problem. What did they do from here to here? Multiply what? So they took this 2 and they multiplied this side by 2 and this side by 2. These 2's canceled or disappeared. That multiplicative, and then multiply these by 2. So multiplication or multiply. From step 2 to step 3, added 1. Okay, let me just say that out. I'm sorry. And then from step 3 to step 4. Add it again. You guys are gonna do number 2. Do we have any questions on number 3? No. I'm gonna give you a minute to do number 2.
Oh, they covered it. Yeah.
Alright, let me give this a second here.
You may have gotten an A, but it
So those two should have been subtraction and then multiplication. So to get rid of the 10, they subtracted because we're doing the opposite. And then because we're already dividing, the opposite of that is multiplying. So we have to multiply both sides by negative 3 to get rid of that negative 3. So this is just showing you how they would be solved, how we're going to solve, and what those equalities are called. But now let's actually do some solving problems. So the answer to this question is kind of what we put before. Guys, stop talking. To find a solution that makes the equation curve. So before we talked about what a solution was, and this just kind of reiterates that, but adds solution in it. And then we kind of talked about these already, but these are inverse operations, so whatever we're given, we have to do the opposite of, so think of inverse as opposite. What is the opposite or inverse? Addition, subtraction, so I'm going to draw a line that connects these two. You can actually write it to either or. The opposite of division, multiplication. The opposite of squaring something. So if I had 2 squared is what? 4. And if I take the square root of 4, what is that? They kind of undo each other. And then cube root and cube undo one another. So if I cube 2, 2 to the 3rd power is 8. The cube root of 8 is 2. So these are really, if you need like what's my first step? What should I be doing first? Distribute if we can. Yes. So not talking about these equations out there. So if you can distribute, do that. That won't always be the case. Sometimes it will. Combine like terms if you have them, but on the same side. We'll talk about doing stuff on other sides in a second, or next class. Move the constant or the number by itself by adding or subtracting, and then your last step is usually get the variable by itself by multiplying or dividing. So some of these you may have done similar problems to before, and that's fine. Some of them you may have never seen problems like before, and that's also okay. We're going to go through these. For number 1, we need to get x completely by itself, so we need to get everything away from it. We need to get rid of the 3 and the 2. Because the 3 is connected directly to the x, we're going to wait to do anything with the 3 and get rid of the 2 first. It has a negative, so we need to do the opposite. So we're going to do what to get rid of the 2? To the other side. Then to get x by itself, we would do what? 5. Remember, anything next to one another, they are multiplying. We just don't see that dot or parentheses. Now we're going to go back and make sure that this solution actually works for this problem. So I'm going to put 2 back in for x and make sure it works. So we should always be checking our work. 3 times 2 is 6. 6 minus 2 is 4. That does work. That was supposed to be a check, not a V. Well, I need to do some talking. One and 2 are very much like the problems we saw on the last page. So we'll do 2 and then we'll move on to some other ones. So number 2, we're going to get m by itself. What do you think we would do first? Aminata? So we're already dividing by 4. We would have to do the opposite. But because that 4 is attached to the m, we're going to hold off on doing anything with the 4. So what would we end up doing? Subtracting the 2 on both sides. And then how would we get m by itself? On both sides. So when we do this, that multiplicative inverse happens, they cancel out. You could also write it as 4m over 4 and then simplify the 4. But you could also skip that step and just know that they cancel. And we're going to put this back in and make sure it works. Divided by 4 is what? 8 by 8. Plus 2 is 10. So that does work. Yes. How did you do that? Originally? Yeah. The 4 is 10.
What? 8. Oh, yeah.
Any other questions on number 2? We're going to move on to number 3. We're doing notes right now. So number 3 is very similar, but now we have that fraction. Don't let that throw you off. We're still trying to get p by itself. What would be the first thing we need to do to get p by itself? Add 25 to both sides. Is that 1? Yes.
So, is that going to be final answer?
For the final answer, that's fine. Either or, unless it's like a repeating distance.
But what's in a problem?
Yeah. So now we have 2/3 p equals 140. To get rid of this, think about this as what are these two things doing to each other? We're multiplying these two because they're right next to each other. Yes, this is a fraction, so that is dividing. but these two things are multiplying to each other. So to undo that, we would divide.
You have to return the fraction.
And then afterwards, I'll show you what happens. So in our calculator, we're going to put this in our calculator. So I'm going to put a fraction. And then I'm going to go to my denominator, and I'm going to add another fraction. So it looks like that. And then put all that in. So alpha y equals with your fraction bar. So I'll do it again. Alpha y equals to get your fraction. Go to the denominator at the bottom. Add another fraction. And then put that entire thing in. You should get 210. Now, that may seem a little confusing because we started with 140, but we ended up with a bigger number. But we're dividing by a fraction. So what really is happening in our calculator, anytime we divide by fractions, and in math we don't really like to divide by fractions. Let me write this. So when your calculator divides a fraction, what you're really doing is taking that fraction, so I'm going to rewrite this, flipping that fraction, so it's now 3 over 2, and multiplying by that flip fraction on both sides. So if you put in your calculator 140 times 3 over 2, you should get 210. Do that really quickly. 140 times 3 over 2.
Without each word, right?
Which one are you talking about? So anytime you divide by a fraction or need to divide by a fraction, flip it and multiply. Or do single fraction. Yes.
You're on the zero. Okay. Oh, the chef. Yeah, it's 2/3 times 210. Yeah, you did it. You got it right. You did it right. Well, you're not really dividing through multiple. So. Still hurt now, or do you want to keep following?
Great. So anytime you have a fraction and you need to divide, you're going to multiply. This is called the reciprocal. When you flip it, we're going to multiply by the reciprocal on both sides. Now, to put this back in, I'm going to use 210. It would be 2/3 times 210 minus 25. I'm going to put this all in my calculator at the same time instead of trying to do it separately. So alpha y equals, give me that fraction. Multiplied by the number we got, that 210. Subtract 25. And we got 115. Do you have any other questions on number 3? That's fine. Number 4 we're gonna skip because I'm gonna let you guys do that. We're gonna do number 5 and then number 6. So number 5, we have parentheses. Multiply the -3. What do we get after we multiply? Whatever variable it has, make sure you keep that, or if you change it, make sure you change it back. That way it stays consistent. If you start off with an X and then it's supposed to be Q and then you don't put it back, you may get confused. And then how would we solve this? Subtract 3 on both sides. And then do what to the -6? Divide on both sides. That actually makes sense because I think that was another one where the letter jumped off the page and I just wrote it in. So, maybe I'll fill in. Go back, check your answer. So this will be like your order of operations. Make sure if you're doing this, not all in the calculator at once, that you're doing everything on the inside. So multiply first, and then subtract, and multiply both sides. Blank space on the back. Not really. Somewhere up towards the top, or anywhere where you have some blank space. We're going to do this one again, but we're going to do it a different way. So, in your mind, you see parentheses, you multiply, you distribute. That's fine. This way also works, but it only works if this number outside if we can divide by that number. So if this is a factor of x, if this was like 16 and this was -3, this wouldn't work. Then you end up with fractions or decimals. You want to avoid that.
So always a number can go into the.
So -1 will always work, but anything else you have to see, does this go into this number? If that is the case, I can divide both sides by -3. I'm not breaking any math rules because I did it to both sides. These -3's divide and just become 1. One times anything is just whatever else it multiplied to be. Really, you could skip that step. And then you could still solve for x. It would be different than how you solved it before. but you're gonna get the same thing.
Thank you.
Add 1 to both sides. We would get -4. Divide both sides by 2. And we still get that x equals -2. So if you have a problem like this, and you have a number outside of parentheses that goes into that final result, you can do it this way. If that is not the case, just distribute. Any questions on that method? Erica, did you have a question? Number 6, we're going to do 2 different ways. So if you see a problem with 6, think which way you like best. Someone read the problem out to me. It's okay. All of that. Yeah, it's okay. There's one. Alright, the first way we're going to deal with the fractions, the second way we're going to get rid of the fraction. So the first way you may not like, that's okay. If you like the second way better, that's fine. So to deal with these fractions, the only way we can combine or add fractions is if they have the same denominator. Right now they do not. To get these to have the same common denominator, we need to think of a multiple these both share. Some number can multiply to get both. So 6. So I would need to think, okay, what would I do to multiply 3 to get 6? So we multiply it by 2. What I do to one part of the fraction, I have to do to the other part of the fraction, kind of like equations. So I also need to multiply my numerator by 2. Then, for this fraction, since I'm trying to get this denominator to be 6, I need to multiply it by 3. And I also need to multiply the numerator by 3. So this method works because I'm trying to combine fractions. I'm not moving things or adding things to the other side, because that would be different. So we would have 4x over 6 plus 3x over 6. So I'm going to put them all as one fraction. Since these have the same denominator, I'm going to rewrite it. Because they're now in one fraction, I can combine my like terms, that's 4x and 3x. From here, because x is in our numerator, you could multiply both sides by 6 and then divide by 7. You could also rewrite this so that the x is next to it. And multiply by the reciprocal, 6/7. Seven times 6 is 42. 1 times 7 is 7. 42 over 7 is 6. We're going to check the answer at the end. Do we have any questions on this method? Okay. Now, somewhere where you have space, rewrite that because we're going to do it again. So this way is if you want to start off by getting rid of the fractions. Rid of is what I meant. Anyway. So if I want to get rid of the fractions, I need to somehow multiply this entire side by something that's going to get rid of both of these. So again, that multiple. So I'm going to use 6 again. I'm going to multiply this entire side by 6. But because I am now multiplying the side by 6, what I do to one side of the equation, I have to do to the other. So, yes, Erica.
So you chose 6 because 3 and 2.
So if it were 3 and 1, I could use 3. It just depends on your denominator. Okay. I'm going to go ahead and distribute across and then start simplifying. When you get more used to this, you could simplify as you distribute, or when you put it in your calculator, simplify. But we're going to go directly across. Remember, this is really 6 over 1. So I'm multiplying 6 to 2 and 6 to 1. 6 times 2x gives us 12x. 1 times 3 gives us 3. 6 times 1x gives us 6x. 7 times 6 gives us 42. Right now, you're probably thinking, well, we still have fractions, but they'll go away. Now we can simplify. 12 divided by 3 gives us 4. 6 divided by 2 gives us 3. And now we no longer have fractions. Now we can combine our like terms and solve for x. This person put both of those methods on the board right there if you miss any of those steps. So the first way was dealing with the fractions. The second way was getting rid of those fractions. If you get a problem like this, choose which one you like and do it that way. Before we do the check method, anyone have any questions? The process for either or is not difficult, it's just a lot of steps. Does that make sense? I'm going to put 6 back in to check our work. Put 6 in for all of your x's. So this gives us 12 over 3, 6 over 2 is 3, 12 divided by 3 is 4, 4 plus 3 is 7, that does work. we're gonna do one more and then I'll let you guys practice. So of number 7, number 8, and number 9, which of those would you like to do together? 7, 8, and 9. I heard 9. And then I'll let you guys know, and we'll look around. So for number 9, I need to distribute, so I'm going to do that first. Multiply this to everything inside here, and bring everything else down. So that part's not really new. And then we're combining like terms. Remember, when you do that, it's whatever it says. So 4m minus 15m. Now it looks like some of the simpler problems. Solve for m. Add 50 to both sides. And divide both sides by negative 11. What is m? Four minus 15. Unless I did my math wrong, which still happens. Check your work. Put negative 16 back in for all of your m's. I'm going to put this all into the calculator instead of trying to simplify this all at the same time. Four times negative 16.
It's a positive 3
Equals 126. Have about 16 minutes left of class. I want you to try and do as many of these as possible. 3, 4, 7, 8, 10. You can work together, compare answers. If you have questions, we'll be walking around. Please ask good questions. And then this person, you can stay for that or you can leave either.